next speaker, Dr. James Reuter, is the Deputy Director of the Space Technology Program of the Office of the Chief Technologist. He has his PhD in Mechanical and Aeronautical Engineering and has done quite a lot of interesting things in NASA and in other private industry as well. So I'll go ahead and turn it over to him, Dr. James Reuter.
I don't need to be up there.
Okay.
So can we go ahead and get to the slides? All right. So I know the program kept changing what was in there about what I was going to speak about today and who was going to speak. Mason Peck, who is the Chief Technologist at NASA, was actually supposed to be here, but he couldn't make it, so I substituted in. And then what I was supposed to talk about kept changing, but what I am going to talk about is just give you guys an overview of what the Space Technology Program is, what the Office of Chief Technologist is, and then give you some specifics on how that is applied to the NewSpace community. So I'll try to talk a little bit about that. The Office of Chief Technologist is new within NASA as of 2 years ago. It has several functions. It serves as the primary advisor to the NASA administrator. It looks at technology investments across the whole agency, all of NASA, in other words, not just OCT itself, but all the other mission directorates, whether it's science, whether it's human exploration, whether it's aeronautics. The Office of Chief Technologist looks at all of those technology investments that NASA does and tries to coordinate them. It also leads the tech transfer for NASA. So all the technology that is transferred outside of the government is led out of the Office of Chief Technologist, and it advocates for research and development programs on behalf of NASA across the country, to other government agencies, to industry, to academia, on the Hill, to our stakeholders in the White House and in Congress. It demonstrates and communicates the societal impacts and benefits that space technology and technology investments within NASA have for the greater community, as well as the space enterprise. And it also has a technology program, the NASA Space Technology Program, as its programmatic element. That's where it makes the investments on developing technologies, demonstrating technologies. That portfolio exists within the Office of Chief Technologist. And so that covers those elements that it does. So I'm going to focus now not on the Office of Chief Technologist, but that programmatic element within the Office of Chief Technologist, which is the NASA Space Technology Program. So what the NASA Space Technology Program is about investing in the high payoff technologies that industry has a hard time covering on its own. In other words, there's always things out there to mature, to increase the whole space enterprise, access to space, doing things in space, new markets in space. All of these things are enabled to some extent by space technology. And of course, while industry is looking to increase its footprint in the overall space enterprise, if there are technologies that enables this to occur more affordably or more expansively, then oftentimes it's up to the government to step in where it can to allow that to occur. And that is what the Space Technology Program is all about. It's also about taking NASA back towards the cutting edge of technology. So technology is a two-way street in the sense that sometimes it's big government programs that develop new technologies, whether it's DARPA or NASA or other government agencies that will invent or come up with a new technology that infuses its way into the private sector, and the private sector then uses that to base our technology-based economy in the US. However, there's other times where the technologies come back the other way, where we realize that what we're doing in space is antiquated technologies compared to what the private sector is doing. So It's also important that, from a NASA perspective, that we maintain this two-way street of technology development. The Space Technology Program actually has 9 technology programs within it. These technology programs span the entire spectrum of technology readiness level. That means very long-term, very immature, just concept ideas that we consider low TRL or low technology readiness level, all the way up to places where we invest in technologies and demonstrate in them in the relevant environment of space, such that they can be infused into future missions, whether that be commercial missions, other government missions, NASA missions. So it is the approach that Space Technology Program overall uses is to apply those technology investments across this entire portfolio. Let me see if I can get a pointer here. Okay, and these top 3 technology programs, the Game-Changing Technology Program, Technology Demonstration Missions Program, and Small Spacecraft Technologies Programs, are that endpoint where we're trying to develop, prototype, execute technologies, and demonstrate them in the relevant environments, including performing space flights of those technologies to show that, in fact, they're ready to hit the prime time and be used by the commercial sector as well as in NASA missions. This middle row that has the Space Technology Research Grants, NASA Innovative Advanced Concepts, and the Center Innovation Fund, those 3 programs are all focused more towards the low TRL segment. In other words, these are technologies that are just concepts, they're ideas, they haven't even been necessarily proven, but you want to see, does that technology have a future? And so you mature them to the point where later they could be moved up into these other 3 programs. And that occurs here in the research grants by having focused university investments. This is where we have fellowships. At this point, we have about 130 NASA fellowships where we're funding the graduate student education of students across U.S. universities, having them spend time at NASA centers and getting their degrees so that they could populate companies, industry, other NASA centers, and other government agencies as well. I mean, the number of fellows that we actually put through the NASA Space Research Grants Program is far larger than the number of people that NASA would ever hire. So it really is out there to push the best ideas and the best people to invest their careers in the space enterprise. The other 2 programs also focus on low TRL work. And these down here are more focused on developing new markets or new business approaches to technology investment. So for example, the Centennial Challenges program, instead of NASA writing a contract, which we do up here in these programs to develop a technology, or issuing grants, which we would do in this program to develop technology, here we offer a prize incentive. And we say, come and win this prize, and if you do, you get the money, and you prove that the technology works. It's up to you to figure out how to win that prize. NASA's not managing it other than just providing the prize purse. Here we have the small business program. All government agencies in the country must have one of these small business innovative researchers programs. So there's a percentage of NASA's money that always has to go to SBIR programs. And of course, that is to incubate small businesses across the country. And then the Flight Opportunities Program is saying, well, there's a lot of folks out there trying to invent better ways, more efficient ways, more capable ways of getting to space or getting to near space. Near space is suborbital. And so there are many small companies like out in the Mojave and other places out in New Mexico that are trying to do this today. And so they need a market to be able to say, hey, there's a good reason we're doing this. So what this program is about is doing two things. It's putting those flight services providers onto a NASA contract where we could say, hey, we could pay for some of the rides that you guys are going to be able to provide. We're also developing a pipeline of technologies that could serve as the components that would benefit from a ride to near space. So in effect, we're playing both sides of that chicken and egg game to create a market space. And why we are doing this is to allow for a bridge to being able to do a quick development of access to space. So how does the space technology programs executed within NASA? This is an important point because if anybody in the room has a history of how NASA has developed technologies in the past and space technology programs in NASA's history, they'll quickly tell you that NASA has been in a feast or famine cycle with regard to technology development. There are times where we do very little technology development and it gets cut from our budget, from the overall NASA budget, and there's times that we have a space technology program and we're up and running for a few years. So one of the usual criticisms that we get when when NASA has had a space technology program in the past is that it's self-serving. In other words, NASA takes that money that Congress has authorized it to spend and does what it wants to do with it without really talking to industry or figuring out what it should be doing, and it turns into open-ended research programs that don't seem to be goal-driven. In other words, what are they doing with that money? Why are they spending 20 years and seemingly no end of this research activity, nothing that benefits the public at large or the commercial sector? And who's telling them that's the right investments to do? So what we've tried to do this go around when we set up the space technology program 2 years ago is we said, okay, there's some fundamentals we want to get right here so that we in fact can have a sustainable program. One is that whole spectrum of technologies, not just low TRL, far out technologies, and not just near-term technologies that could have quick payoffs in the next couple of years, but that entire spectrum. Previous programs have focused on one or the other. Additionally, we want to know have a clear strategy for our investments. This is where the space technology roadmaps come in. We actually created a set of space technology roadmaps, and we had them vetted by the NRC, the National Research Council, that essentially is the academic institutions coming together and saying, we're going to give you some top-down cover for saying that you guys are doing the right thing. The NRC weren't just a few guys in a room saying this is what NASA should do in terms of its technology investments. It actually pulled in industry, academia, other government agencies, and the public and vetted these technology roadmaps to decide what is the priorities that NASA should invest in the future. What technology are the low-hanging fruit that we need to get done quickly? What are the longer-term investments that we also need to invest in? So they gave us this report in about May of this year. It's been all finalized at this point, and so that sets our priorities for our future investments. It's not NASA deciding what our investments are going to be. It's these technology roadmaps that set the priorities. We invest in a comprehensive portfolio. I've already talked about this. And we advance both transformative as well as cross-cutting. So the technologies that the Space Technology Program invests in isn't just one technology that's only applicable to one mission for NASA. They are technologies that are cross-cutting. They have application for commercial folks. They have application for other government agencies. They have application for NASA missions as well. And an important point is we're using merit-based competition, which means that we have many solicitations out on the street, which means that the best ideas and the best people with the best proposals actually get to do the technology development activities. It isn't just a pipeline of funds to NASA centers to perform the work. NASA centers have to compete with everybody else to get funding to do technology development. And then, of course, we're talking about project execution, which means this isn't an open-ended research grant that you just continue to have money to do what you want to do for a career. It is a finite time period. You have a clear start date, you have a clear end date, you have a clear budget, and you have clear milestones. You don't make your budget, you don't make your milestones, we terminate the project. I mean, it's that simple. Okay. So another policy or principle is infuse rapidly or fail fast, which means that we either get the technology done and we get it into the hands of a customer that could use that technology, or we figure out the technology is not going to work, or there's no customer at the end of the line to say they need it, and we kill it. Portions of the NASA, positions NASA at the cutting edge of technology. So this I talked about earlier about balancing the technology infusion out to the commercial sector, as well as relying on emerging technologies that are coming from other domains and infusing them into the space enterprise. All right. So this is just a status, give you an idea of how we're funded. We had $350 million in space technology program in FY11 and $575 million in FY12. This gives you the number of projects and programs that we're actually involved in. And what I wanted to point out here is this is just the number of solicitations. These are the number of things that we have out there right now that people are proposing against. And if you will note, the important point here is that we're about to make a bunch of awards this month and next month. There's a very large number of awards coming out from all of these programs. And of course, this sets us up for next year's round of solicitations once these are done. So we're going to have a cadence of solicitations where various folks from outside industry and academia and NASA centers can compete for these activities. These are our most important or most highly visible technology projects: laser communications, cryogenic propellant storage and transfer, deep space atomic clock, large-scale solar sails, low-density supersonic decelerators, and the rest. These are the most high-profile, most near-term technologies that will rapidly infuse or fail that we have in our pipeline right now. There's two new ones that we're adding to that list this year. We're going to have an award fairly soon for solar array systems development. Current technologies for solar arrays have been around for a while. They're used on large communication satellites all the way down to the smallest satellites out there to power them up. However, that technology is sort of at its end point as far as extendability and also how much power you're getting for the area and the mass of the systems. There's emerging technologies that have been out there for a while, but they've lacked the opportunity to have a space demonstration. We're actually going to mature those technologies, compete a few of them against each other in a development environment, and then go fly the winner of those once we got to a certain point. We're also doing green propellants. Hydrazine is the monopropellant of choice that most spacecraft use in order to get around in space, reaction control, getting to and from orbit. Hydrazine has been the easy-to-store propellant of choice. The problem with hydrazine, of course, it is highly toxic and very difficult to handle on the ground, difficult to transport. So we're actually going to have an award this summer in where we're going to fly and demonstrate a replacement to hydrazine. Okay, so I'm not going to go into these because I have to end quickly, but I wanted to point out that this is our fellowships program. We had 80 fellows our first year, and we have about 50 fellows that are starting this August, so that gets us up to about the 130 fellowships time period. We also have other university grants as part of that program. The NASA Innovative Advanced Concepts program is really looking at advanced concepts 10, 20 years in the future, and how these things could change the way we do this whole space enterprise. And it is study concepts, determining whether missions work or don't work. That's the whole perspective of that program. And let me talk a few minutes to end my talk about the whole spacecraft, small spacecraft aspect of this. Why is NASA making these investments in small spacecraft? Well, there's a convergence of many ideas coming together, from citizen space exploration, the ability to do rapid development for small spacecraft, the open source approach that is used in the software industry, and how that could apply to interface standards, the innovative culture that is emergent in that community, and new solutions and new investigations. So, continuing, if you look at the old paradigm of how space architectures were developed, they started off big and they got bigger. Here's a small space telescope to test out that idea, and then we go up to Hubble. The next one above this is James W. Space Telescope, and each time they do this, they magnify the cost just because of that size. This is also true with comm satellites. Well, we need to change that paradigm, and NASA truly does believe that there are ways to change that paradigm, so we rethink the fundamentals by starting small and staying small or getting even smaller. That's the way that we want to do that. Now, why would we want to do that? Is that we know that costs are driven by size to a large extent. There's, of course, launch costs, and while it is true that the smaller launchers actually cost more in terms of payload per pound to orbit, it's also true that, that the cost of putting a spacecraft into orbit, your ticket to space, is still driven by these very large numbers. Down here, even if you go to something like SpaceX, you're still at $2,000 per kilogram to orbit. So those are very high costs still today in order to access space. Secondly, anyone that's building hardware will tell you the heavier whatever you're building is, the more expensive it is. So I don't have multipliers here, but this is a multiplier between here and here. It's also true that if you have smaller spacecraft, there's less time in terms of schedule and risk to putting it together. You could build a lot of small spacecraft, test out a few of them, and then even if you have a few failures, you could go back and fix it. If you throw everything into one big spacecraft, then it's much more expensive to make the systems engineering of that correct, so you burn down the risk through more testing. So when you multiply all these together, what you get is a radical reduction in the entrance cost to getting to space. And that is why NASA is actually making this investment. Okay, I'm going to skip forward here, and I'm going to skip these programs. I'll just highlight the fact that we have the Flight Opportunities Program that I mentioned earlier, where we're creating a market space for the suborbitals. And we also have the Small Satellite Demonstration Mission Program, where we're actually putting into action this philosophy of saying, hey, we want to go small, we want to prove out that small spacecraft can be used for things that couldn't be done with large spacecraft, and the entrance price to space is so much lower that if you can do the things that we currently do with small spacecraft, it'll fundamentally change the entire space enterprise. And I'll end it there. Across the whole agency, all of NASA, in other words, not just OCT itself, but all the other mission directorates whether it's science, whether it's human exploration, whether it's aeronautics. The Office of Chief Technologist looks at all of those technology investments that NASA does and tries to coordinate them. It also leads the tech transfer for NASA. So all the technology that is transferred outside of the government is led out of the Office of Chief Technologist. The slides? All right. So I know the program kept changing what was in there about what I was going to speak about today and who was going to speak. Mason Peck, who is the Chief Technologist at NASA, was actually supposed to be here, but he couldn't make it, so I substituted in. And then what I was supposed to talk about kept changing, but what I am going to talk about is just give you guys an overview of what the Space Technology Program is.
Next speaker, Dr. James Reuter is the Deputy Director of the Space Technology Program of the Office of the Chief Technologist. He has his PhD in mechanical and aeronautical engineering and has done quite a lot of interesting things in NASA and in other private industry as well. So I'll go ahead and turn it over to him, Dr. James Reuter.
I don't need to be up there.
Okay.
So can we go ahead and get what the Office of Chief Technologist is? And then give you some specifics on how that is applied to the NewSpace community. So I'll try to talk a little bit about that. The Office of Chief Technologist is new within NASA as of 2 years ago. It has several functions. It serves as the primary advisor to the NASA administrator. It looks at technology investments across, and it advocates for research and development programs on behalf of NASA across the country, to other government agencies, to industry, to academia, on the Hill, to our stakeholders in the White House and in Congress. It demonstrates and communicates the societal impacts and benefits that space technology and technology investments within NASA have for the greater community, as well as the space enterprise. And it also